So this is a walkthrough for the basic derivatives homework assignment. We're just going to be using the power rule here for these derivatives. So we can use the power rule whenever it is a function that's in the form x to the power of n, where n is any real number. And we can have a coefficient out in front of that. We can have multiple functions added together, and so on. So to do this first one, first we'll just write f prime of x, because that notation is what means the derivative of f of x. And then we will take the 5 that is in the numerator, multiply it by the 3 that's out in front, and then we will drop the power of the x by 1, right? Because if f of x is equal to x to the n, then f prime of x is equal to n times x to the n minus 1. And the constant out in front, to begin with, doesn't affect this. It just gets multiplied through. So this answer here should be 15x to the 4th power as our derivative. And so normally you wouldn't write out this whole step right here. You'd just go straight to the answer. You definitely want to be able to go straight to that answer. So here we've got just a couple different functions being added or subtracted. We can just treat each one individually. So 3x to the 4th, we'll do the 4 times the 3 gives us 12. And then x to the power of 3, because 3 is 1 less than 4. And then we'll move on to the next one. We'll do minus 24. And then it'll drop down to x to the 1st power. Of course, we don't need to write a 1st power on there. And then the plus 3 will go away because the derivative of a constant is 0. If we don't quite remember why that is, remember that a constant is just, a horizontal line, right? Y equals 3. And so its slope is always 0, therefore its derivative is 0. So we get 12x cubed minus 24x. If we have fractional exponents, right? If we have rational exponents here, there's no issue. We just do the exact same rule. We'll multiply by 2/3 out in front, and then we'll do 2/3 minus 1. Well, 2/3 minus 1 is negative 1/3. So 2/3 x to the negative 1/3. And then minus x to the negative 1/3, well, we'll do a negative 1/3 times the negative that's out in front, which will make it a positive 1/3 x to the, now we do negative 1/3 minus 1. Well, that's negative 4/3. So it's plus 1/3 x to the negative 4/3. Same thing here. We'll multiply the 2 by the 5/4. 2 times 5/4 is 10/4. Right? 2 times 5/4 would be 10/4, which will reduce down to 5/2. So that will be 5/2 x to the, now it's 5/4 minus 1. And so 5/4 minus 1, that's 5/4 minus 4/4. That's just 1/4. So we have 5/2 x to the 1/4. And then we'll have minus 6x, right, because it's negative 2 times 3. And if we do negative 2 minus 1 for that exponent, that gives us negative 3. So negative 6x to the negative 3. And then the minus x is just going to become a minus 1, because it's like x to the 1st power. And then if we multiply by a 1 out in front and then drop down to the power of 0, that x to the 0 is just 1. And since we had a minus sign out in front, we keep the minus. So there's our derivative. For this one, we're going to do just a quick step first. We're going to rewrite this as x to the 1/2 power, because we know that a square root is just a 1/2 power. And then we're going to write this as x to the 1/3, because a cube root is just x to a 1/3 power. Now we'll use that power rule. We'll get 1/2 x to the negative 1/2, because we pull the 1/2 out of the front. And then 1/2 minus 1 is negative 1/2. And then it'll be minus 1/3 x to the negative 2/3, because, well, 1/3 minus 1 is negative 2/3. So we're just using the power rule here, right? still just n x to the n minus 1 every time. For this one, the 3x, the x will go away because 3x to the first, when you take its derivative, becomes 1 times 3x to the 0. And x to the 0 is 1, so 3x is just 3. The minus 3 is a constant, right? And that just goes away because its derivative is always 0. And then we'll have minus 9, because 3 times negative 3, and that last term is negative 9. X to the negative 4th power, because, well, negative 3 minus 1 is negative 4. Now this one we have an irrational exponent, but that's okay. That doesn't affect us and our ability to use the power rule. So f prime of x should just be, well, multiplied by that power out in front, so pi x, and then drop it by 1, pi x to the pi minus 1. And that's all it is. This one sometimes trips people up. We have e squared. A lot of times people look at that and say, oh, it should be 2e, right? 2e to the first power. But no, e is just a number, right? So e squared is just a number, and a number is just a constant. Derivative of any constant is 0. And we'll just get 2 more here to go. So f prime of x here should be, well, x to the 10th becomes 10x to the 9th. The x squared should become a 2 out in front, x to the first power, but once again, we won't write that first power. The negative 3 times a negative 2/3, we'll write that over here if we want to. Right? The negatives cancel and the 3's cancel, so we're just left with a positive 2x to the, and then negative 2/3 minus 1, that'd be negative 2/3 minus 3/3, or negative 5/3 power. And then the last term, the 4x to the negative 5, 4 times negative 5 is negative 20. And then it's x to the negative 6, because now negative 5 minus 1 is negative 6. And the last one on this homework assignment, as I look through, I noticed that all of them are kind of in a nice power rule form, except the square root of x. So I'll just think about that as x to the 1/2 when I get to it. I'm not going to really rewrite the whole thing, but I'll just note that that one's x to the 1/2. And my derivative here should be 5 times negative 6, which is negative 30. X to the negative 6 minus 1, or negative 7th power. And then minus 12, because 3 times 4 is 12, x to the 3rd power. Minus x, well, that's like x to the first, and we already talked about that. That's going to drop down to become minus 1x to the 0 power, but we know that x to the 0 power is just 1, so we won't bother writing that. Then we have our x to the 1/2 that we said was the same as root x, so that will become plus 1/2 x to the negative 1/2. And then lastly, we've got a negative 5 down there times a negative 4/5. 5's and the negative signs cancel, so that just becomes a plus 4x. And then the power is negative 4/5 minus 1, while negative 4/5 minus 5/5 would be negative 9/5. And that should be it. And remember, what we're doing is we're finding derivatives using the power rule here, or the derivatives of constants sometimes. And this is just telling us what the instantaneous rate of change of the function is, or we call that the slope of the function, or it's also the slope of the tangent line to the function. And that's it for our basic derivatives homework assignment.